So, first question, okay, number 13. The target is fired with an angle θ to the horizontal plane with initial speed u. It has to clear a fixed wall which is 90 meters high and a distance 240 kilometers away from the point of firing. If sin θ equals 3 over 5, find the minimum value for u to clear the wall. Okay, so first thing we're going to do is we're going to work with sin θ equals 3 over 5. We're going to make a 3, 4, 5 triangle. So it's going to be the hypotenuse is 5, the opposite is 3, and the adjacent therefore is going to be 4. Okay. The next piece of information we're going to have is that the s of x is going to be 240, and the s of y is going to be 90. Okay, so you have to construct your two formulas. Mainly, it's going to be the sx formula and the sy formula is what we're going to use. Okay. 1 second. So, 1 second. There we go. Okay, so 4, 3, 5, θ. Okay, so we're right away. So the projectile gets thrown, and then at a certain point, there's I am sure if it's on its way up or its way down. I really don't know. Okay, it doesn't even matter. So what's going to happen is we have a projectile. We have a wall here. This wall is located. It's 90 up, and it's located 240 to the horizontal. So your two information is sx equals 240 and sy equals 90. So in a test, if you're looking to skim a bit of time management, you're going straight into the sx and sy equation. So s equals ut plus a half at squared. Therefore sx is now we have to sort out u now. Okay, so we have to figure out what uy and ux is. So this is u. This is going to be u cos θ, and this one's going to be u sin θ. U cos θ is 4 over 5u, while u sin θ is 3 over 5u. So that's for the u value. So sx equals u times t, which is going to be 4 over 5u multiplied by t. There's no acceleration in the x direction, so the half at squared part is 0. For sy, the u value is 3 over 5u times t. Gravity is in this one because gravity is minus 9.8, so acceleration is minus 9.8, so it's going to be minus 4.9 t squared. Okay, there are two formulas. So what we're going to do with the first formula is we'll isolate t. So s of x equals 240. So multiply by 5 and divide by 4. And what we're going to get is 300. So using the sx formula, we're going to find out that ut ends up to be 300. Therefore, t equals 300 over u. Now we can enter that into the sy equation. Yeah. Enter that into the sy equation, so sy equals 3 over 5 multiplied with 300 over u minus 4.9 times 300 squared is sorry? Between 3 over 5 and 300 over u. Oh, there's another u. Here? Yeah, thanks. And then this one here is 4.9. So what's 300 squared, lads? Is it 90,000? Now, we're going to replace SY with 90. And we're going to need somebody in the calculator for this, because there's a lot of big numbers on this one. So, we're looking at here is I can just get rid of that. Okay, so what?
Is that where did that U squared come from?
The U squared, it's, see the T squared here?
Oh, it's nothing.
And then that's T, so we'll just square it. Okay.
So,
Yeah.
how did you get UT equals to UT?
Okay, that comes from this here.
Yeah.
So multiplied by 5, and then divided by 4.
Alright.
So 4 times that is 1,200. And then UT will be 1,200 divided by 4, which is 300. And then I brought the U underneath. Okay, good questions, guys. Keep them coming. Next thing is going to multiply all these out. So we're going to have 90 equals, what's that going to be? 900 over 5. Are we happy with that? Use cancel. 3 times that, 900 divided by 5 is 180.
Yeah.
Don't. What's 4.9 multiplied by 90,000? Anybody?
441,000.
Sorry? 441?
000.
Okay. All over U squared. Okay. Interesting. Bring the 180 over to your side. We get minus 90 equals minus 441 and the 3 zeros there. What we're going and the U squared on the bottom. What we're going to do is we're going to make the 90 and the U squared switch places. So we're going to have U squared equals minus 441,000 all over minus 90. U squared therefore equals 4,900. That puts U equal to 70. Is that right? Any questions on that? Number 14. Oh, okay, so here we are here. A bullet is fired from a gun fixed at point O with a speed v meter per second at an angle theta to the horizontal. At the instant of firing, a moving target is 10 meters vertically above O and is travelling with constant speed 42√2 at a constant angle. Ooh, that's different. Constant angle 45 degrees to the horizontal. The bullet target moves in the same plane. Now this is an interesting one, okay? So what you have here, it's not like your, it's not like the bird and the jet fighter one. So we have a target at the start. Make it look like a target. Bullet is down here. Now, what's different about this one than the last one is that it's moving at the same instant firing. The moving target is 10 meters. So at the start, we're talking about a 10 meter difference. Okay, and this guy is 10 meters here. Now, and what's going to happen is instead of moving directly across like we've done in the past, it's moving up this direction here. Okay, and what we're hoping is that our bullet in the red trajectory is going to come up, going to get fired off initially, then it's going to do its whole projectile thing, and we're taking the first time it hits and not the second time, okay? If it is to hit it at all, okay? Or it could be just one where it just clips it, and then it could be either, I don't know yet, okay? So, okay, so what we're going to do is something. Can anybody tell me what has to be exactly the same for the bullet to hit the target? It was in the bird question and it was in the jet fighter question.
It's speed.
It's X speed. It's speed going left to right has to be identical. So that makes my job easy here, because what I can do is I can look straight at the target, not the bullets. So the target is going up at 45 degrees. It's going 42 root 2. Now remember what we said, this one will be 42 root 2 sine 45, and that's 42 root 2 cos 45. That's 42 here and 42 there. So the target is traveling 42 meters to the right and 42 meters up in the air every second. What does that mean about my bullet speed? So what do we need to, what can we say about phi x of the bullet then? 42. And therefore, I'm just going to get rid of the diagram now. We get the gist of the diagram here, okay, that it's moving up like that, so the diagram can move off. Okay, so now that we're done with the diagram, okay, so what we're going to do is we're going to do a phi x, phi y, sx, sy on each one. Okay, so we're going to have a target is here, and we're going to have bullets over here. And we're going to work out phi x, phi y, sx, sy for each one. Okay, we've agreed that both phi x's are 42. We know that the target's phi y is 42 as well. The target is not undergoing any gravity. Why is the target not worrying about gravity? It's like on a wire, so it's supported. So remember that like if an object has its own power source, projectiles are only projectiles when they have no power source on them. A target has its own power source, so it just keeps traveling upwards at its speed, as said in the question, right? So it's not a projectile, so it doesn't obey the projectile equations. Okay, so it stays going at 42. Sx therefore is 42t. It's sy. Huh? Now it is the same, but remember that I had a 10 meter head start. So we're talking about 0, 0 being if we're talking about this point being 0 across and 0 up, this one has a 10 meter start at 0, 10. So therefore it's got to be your 42t plus your extra 10 meters head start into the air. Okay. Now we're now onto the bullets. Okay. And with the bullet, we're going to figure out some angles and whatnot. So, how fast is the bullet actually going? It tells us it's 70, doesn't it? So, that makes that 70. We know that it has to go 42, right? Will somebody do Pythagoras for me? Figure out the other side. So 70 squared minus 42 squared, square root the answer.
56.
Huh?
56.
Someday, Rob. Someday. 56. Oh. Nope. Now, prove that the angle is 4 over 3. Well, I can see right now that tan theta is 56 over 42, which is 4 over 3. Everybody happy with that? So I proved the first part, no bother. Now, find out what time after firing does the bullet strike the target and calculate the horizontal distance from the bullets. It wants me to find out T, and it also wants me to find out what is the Sx once I find the T. Okay? Now all this information here, I think we're nearly done with it. We're going to use phi is u plus at. So we're talking about 56 minus gt, yeah? Because it's phi plus u, 56 going straight up. It's a projectile, so gravity is slowing it down. so it's minus 9.8 t. The SX is 42 t. The SY is going to be 56 t. UT plus a half AT squared. So a half of gravity minus 4.9 t squared. Now that we have all this information at hand, everything else doesn't really matter anymore. So all this stuff can disappear off. Now, so we have to find out, let me see. I think we have this, alright? When the projectile hits the target, what is the same? So, mini diagram here. When the projectile hits the target, what's guaranteed to be the same? The SX has to be the same, and the SY. If we put SX equals SX, what do we get? Absolutely nothing, because they're the same equation. So that's not going to do us any favours. We got to look at SY equals SY, which is what I'm going to put down here. It's going to be 42t plus 10 equals 56t minus 4.9t squared. We're going to bring it to the left, so it's 4.9t squared minus 14t plus 10 equals 0. Going to multiply by, suppose I should multiply by 10. So 49t squared minus 140t plus 100. It's actually a reasonably easy one, isn't it? 7t minus 10 equals 0. What does this mean, a repeated answer? What does that mean? Huh? Only hits it once. So if I had two distinctly different answers, it would be where it goes up and back down again. If it's just going to clip it and then back down again, right there. Okay. If I wasn't able to solve this, what would that prove? If it was a minus b formula and I couldn't get,
They didn't touch.
they didn't touch. Perfect. Right. So t equals 10 over 7. Which is good. Now that we have this 10 over 7, we have to find out what is the horizontal distance away from where you began. That's your 42t there. So Sx equals 42 multiplied with 10 over 7. And we only get 60 meters away. Alright, lads.